to use that and work with a gravity mold. And I'm going to show you what that is in 1 second. So to enable form through the acting of both these forces that act out in Puffy Glass, I developed gravity molds. This is one example. It's essentially a wire mesh base, and it is coated with plaster and silica. I've given it a wide base and given it 3 extensions on the base so that it can sit on 3 bricks or stilts, whatever you use to support structures in your kiln. This is how we would set up the mold in one of the kilns like the one behind me. But I'm going to set it up for you on the table so you can actually see it. But in reality, you would put this into the kiln, and then you would put your materials into the mold while it's inside the kiln at room temperature. All right? So you have 3 stilts, set up the mold, and now I'm going to start filling it up. Just for kicks, what I'm going to do is fill one end of the mold with clear glass pebbles like this one. Okay? So this is just clear glass that came out of the furnace, and it is of the same type that Puffy Glass is made. Okay? So use compatible glass. And I'm going to start filling it with chunks of big glass like this, for example. All right. Oops. And see, when the wire mesh is too large and my chunks are too small, they're going to fall out. So you might want to just pick the big ones that will fit. Okay. And I am putting it in there. Okay. And then what I'm going to do is use some of the Puffy Glass that we have to put on a clean surface. Now, if I had added yeast to this, or eggs to this, or a more complicated recipe, I would have let it sit for an hour and actually rise like you do for yeast bread. But I didn't. I just added flour, right? So I don't have to do that. The way I load Puffy Glass is I put little balls in. And the reason I do that is that I have just found that they fit better together, and they don't fit in a big clump or mass, so it's like little balls sticking together. They still have air spaces between them, and that helps with the part of the process in firing where you need gases to escape. At the same time, they're tight enough to actually create sort of even or bulbous form, which I am interested in, at least with this particular mold. All right, so I'm going to fill this with lumps of Puffy Glass, all right, while you watch. This happens fairly commonly, that your balls will fall through the mesh. That's not a bad thing. You just have to stick them back in there in a sort of slightly different form so they don't fall through the mesh. That's pretty much it. All right. All right, so to get color, what I do is I use glaze oxides, and that's partly because I'm from a ceramics background a long time ago, but also because I find that it gives you unexpected but really strong colors if you fire it correctly. Having said that, don't use glaze oxides if you're not comfortable with chemicals and if you don't know which chemicals are toxic and which are not. Email me if you have any questions, and I'm happy to help you through that. The one thing I should probably mention is the right way to powder your glass for this process. The powders that companies sell have facets to them, and which means they pack tighter in your mold. And the whole point of Puffy Glass is to capture air pockets. So you don't want something that is crystalline and will pack tightly. And so I haven't found those to be effective, but if it works for you with what you want to do, you should try that. What I usually do is use a ball mill, which is a jar that rolls on a set of rollers with a whole bunch of ceramic balls in it, and you throw the glass chunks into that jar along with those ceramic balls, and it crushes the glass for you. Now, I haven't filled this mold all the way, but you can if you want to. I usually don't go all the way up because the mold fills up because the material puffs up, but it's your choice. You know, you can fill it up all the way and have something go up or spread out, and that's for you to play with. Now, these parts that you see that look like udders are totally amazing because they actually pull down as the temperature goes up and the silica wants to fall down. They actually go down and then they bloat up. When they do that, you land up with really amazing forms that you may not have designed, but you've set up the sort of parameters for those forms to be created, which is a very different way from what we think of a mold as doing conventionally. So it's a mold that doesn't really give you a specific form, if that makes sense. Okay, so you're going to place this in the kiln, okay? Fire it up. Give it time to vent the organic material. At about 300 Fahrenheit, it will smell like bread, you know. At 600 to 900 Fahrenheit, it is going to smoke. And you want the vents and the windows to the space that you're working in open. At that temperature, it will also fall back on itself, shrink. So whatever is in your mold will actually shrivel, and it will look like a piece of black something in there. By the time you get to 1000 Fahrenheit, you will see the material turning white in its mold. It will appear as though all the black soot went away, and this is your cue to ramp up faster. You can go up to 1450 Fahrenheit, which is what I do, and you do not have to hold for very long at all. If your puffy glass doesn't puff up in the first 5 minutes for larger pieces an hour, it's probably not going to do it. And so you will probably land up with an interesting looking carbon-infested object, like I have in the past. But for a material to be lightweight and puffy, aim for the material to rise both at the top and fall from the bottom, okay? You would crash the kiln, and you will follow a regular annealing cycle. And I have one thing to show you. And ta-da! This is something that I fired using a similar mold about a couple weeks ago, doing the same thing, starting with clear and doing puffy glass on the other side, and this is how it was cast. Once the kiln cycle is complete, you can cut off the wire mesh, okay? Try to do this dry because puffy glass is porous. If water gets inside it, the carbon within the matrix will expand and you will find cracks appearing on the surface. If you land up wetting the surface gently, put it back in a kiln at about 250 Fahrenheit or 100 degrees centigrade for the water to evaporate. Here is an example of a cross section of a piece like this. Okay. This is another section. This is yet another. So as you see, all of these came from the same piece. And as you can see, they're different. Now you can also use needle files or handheld drilling tools to carve into the puffy glass like styrofoam. Just use respirators, okay? And cut pieces up and pick them up in the hot shop with a compatible glass. So textures and forms can be gotten from each manipulation, and they're all very different, and I can go over them in future demonstrations if we have the opportunity. But for now, try baking puffy glass in gravity molds, and do let me know how your experiments go. I'm happy to answer any questions you have. Would love to see images and hear about your discoveries and incidents, and look forward to hearing feedback. Thank you very much for trying this, and I hope you enjoy puffy glass.